I know the title of this lesson is lesson 2.7 and it says distributive property, but we are mostly going to be concentrating on what's called adding like terms. And tomorrow you'll see more on the distributive property. So the beginning part of this lesson, we're working with variable expressions. In your book, it's page 88 to 92. Simplifying them. An algebraic is one or many terms being added or subtracted. So some examples of terms. A term could simply be a number. That's our constant. It could be something like 2x plus 7. An example of terms could be something like 3x to the third minus 2x squared plus 5x. Each of these individuals, and especially when we rewrite this as plus and negative, that I've put a little underline under, squiggly line, are all terms. Some are variable terms, some are constant terms, and none of the ones with squiggly lines are like terms, but we will define all of these as you look at this next section. A term. Terms are expressions that are separated by addition symbols. Key thing, we're always going to change our subtraction to addition if we have it. Like terms. Terms that have the identical variable parts raised to the same power. So 3x and 7x are like terms, whereas in the last example I gave you 3x squared and 7x. These two are not like. Here x is to the second, and we usually don't ever put a 1 in, but it's understood in our heads that that is a first power. Coefficient, you want to add this to your notes. It's the number multiplied by the variable. So here our coefficient is 3 and 7. The coefficient of x squared is 3. The coefficient of x is 7. Constant is the simply best way to put it. It's the number by itself. 1/4, 0.76, -4, when you have a number all by itself. Now, as you are taking a look, terms are always expressions that are separated, and I now say down here by addition and subtraction. Key thing, subtraction is always changed to adding the opposite. Like terms, identical variable parts. Now, some people will sometimes say 4x and x, those are like. Yes, they both have x to the first, x to the first, but we as mathematicians and for the rest of your life will understand that if there's no number in front of x, to always put a 1. As we start working with adding like terms, someone said, well, how does the distributive property fall in? Here is letter S. I would like you to put this one as an example. 5x plus 2 plus 3x. The next letter you're going to write down is F. 3 plus 7x plus 8. And you can have these two in your notes. Now, as you take a look at this problem, we are going to notice I have them highlighted. I like highlighters a lot. 3x and 5x are my like terms. So what I'm going to do is I'm going to regroup them. How? Using our commutative property. 5x plus 3x plus 2. The nice thing about this is that I notice these both have an x in common. I'm going to put the x behind. Inside the parenthesis, I'm going to add 5 and 3. Because of order of operations, 5 plus 3 gives us 8x plus 2. And my answer is 8x plus 2. Why not 10x, or why not just 10? Unlike terms. 8 has an x with it, 8 times x plus 2. Here again, the coefficient of our x would be 8. The constant would be 2. As you look at the next question, letter F, again, we want to rewrite this using our commutative property. And I'm going to put, instead of the 3 first, I'm going to put my variable term. That's called descending order. 7x plus 3 plus 8. You'll notice all the answers are always going to be in descending order, in that they add the like terms and always put the variable power first. So 7x plus, Now we probably don't even need to group these and put them in a parenthesis. 8 plus 3 gives us 11. Again, we cannot combine x plus 11. And if you want to think of the x's, these might be my calculators I'm holding up in the front of class, and these might be notebook paper. We cannot make it into a paper calculator, so if that helps you to think about that problem. Here's another problem. 9 plus 6x plus 2. What about when you get a bunch of things in it? And this is letter O up here. So I would like you to try letter E. Again, notice in O, I highlighted my x terms and I put my numbers in a different color of highlighter. Another thing I'll have students do is just simply underline. Once for our like terms, my coefficient ones, and maybe twice for my constants. Again, we want to regroup it using our commutative property. 9x plus 7x plus 3 plus 4. What is common to the first two terms is an x. So this is kind of the reverse of what we're going to do tomorrow with the distributive property. 9 plus 7 gives us 16x. We also can regroup our constant terms, and our constants, 3 plus 4 gives us 7. We are going to be doing a lot more practice with adding like terms. Some of the problems will have two variables in them, like this letter T here has 3t. Now, you might want to make it into a capital T because for many of you, T looks like a plus. Plus V. Again, in front of any variable, if there is no number, we're going to always put that 1 in. So you can almost do that in all of your problems. Put a 1 in front to help you so you don't get confused. We're going to also put the plus, and in this case it was 7b. Again, using our distributive property and regrouping with the commutative property, we're going to go with 3t plus 1t. Put the 1v plus the 7v. What did the first two have in common? A capital T. 3 plus 1 is how we can think in our head to regroup. 1 plus 7 with the common factor v. So that when you look at this problem, 3 plus 1 gives us 4t. 7 plus 1 gives us 8v. Some of the problems, again, get a little more complicated. If you'd like to write this one down and try it in your notes, we want you to leave some room tomorrow in your notes for the distributive property. Hopefully, adding like terms makes sense to you. Regrouping using your commutative property and thinking about the problem.